So today our lesson is going to be on 6.5, the tangent graph. The tangent function is found by dividing the sine function by the cosine function. For each angle. So tangent of theta is equal to the sine theta over the cosine theta. And keep in mind, if we have this coordinate x and y, x stands for the cosine and y stands for the sine. So this is basically the y value divided by the x value. We're going to go ahead and we're going to graph the parent of y equals tangent of x. We'll start off at 0. We'll do pi over 6, pi over 4, pi over 3, pi halves, pi, 3 pi over 2, and 2 pi. Now, if we look at the graph at 0, right here, remember it's the sine over the cosine, so it's basically 0 divided by 1. So this is going to be a 0 divided by 1, which is just a 0. At pi over 6, we're doing 1/2 over square root of 3 over 2. So when you divide that, you're going to get approximately 0.6. At pi over 4, that's the point of square root of 2 over 2 over square root of 2 over 2. So when you divide this by this, you're going to be left with a 1. Now, I don't know if you noticed, but on the unit circle that I gave you guys, the outside, these are actually the tangents. So here's your x, here's your y. So this is your cosine, this is your sine. Well, the value outside is the tangent. And the tangent is found by dividing the y and the cosine. I mean, the y and the x. So y divided by x gives you the outside, which this is the tangent. So I actually gave you all the tangents. You can also use your calculator. Since this is in radian mode, since that's radian mode, I'm in radian mode, I can type in the tangent of pi divided by 3. And that gives me a 1.7. If I do the tangent of pi divided by 2, that's actually undefined. Let's look at the graph here. At pi halves, right here, that is 1 divided by 0. So 1 divided by 0, you can never divide by 0. So yeah, that is undefined, which to me, that means I'm going to have an asymptote. Because the way it looks, it's going, the numbers are going up. It's just never going to, at pi over 2, it doesn't exist. At pi, the tangent of pi is equal to 0. 3 pi over 2, let's look at my unit circle this time. You can use a calculator if you want. At 3 pi over 2, that's down here. Once again, it is undefined. And like I said, that is going to create an asymptote. This is going to create an asymptote. And then at 2 pi, I get a 0. So just like sine and cosine, the pattern's going to like repeat itself. This is what it's going to look like. I'm going to go by pi over 4. 1 pi over 4. 2 pi over 4 reduces. 3 pi over 4. 4 pi over 4 reduces. 5 pi over 4. 6 pi over 4 reduces. And this is just the negative. So that's negative pi over 4. Negative pi over 2. Negative 3 pi over 4. And then this is a negative pi right here. So we have asymptotes at pi over 2. So here's pi over 2. I'm going to have another asymptote at 3 pi over 2. So basically, every 4 notches, you're going to have an asymptote. So I'm going to have another asymptote right here. At 0, I'm going to graph 0. At pi over 4, I'm going to graph a 1. Now, pi over 6 is right here. It's actually going to be 0.6. Pi over 3 is somewhere right here, and it's actually 1.7. So on this one, what's going to end up happening, it's going to look like this. So just like in sine and cosine, how there was always 5 points, you had to remember where was a max, where was a min, where did it cross the x-axis? This is the same thing. Where are your asymptotes? And then the 3 points in the middle, it's going to cross right in the middle. So it's going to cross right in the middle. Then it's going to go over 1, up 1, over 1, down 1. Same here. If I cross 4 notches, 1, 2, 3, 4, there's going to be an asymptote right here. It's going to cross in the middle, over 1, up 1, over 1, down 1. This is actually 3 cycles here. This right here is one cycle or 1 period. That's 1 period. This is another period. This is another period. Well, look at the value of the 1 period. In sine and cosine, to go 1 full circle, it was 2 pi. But on here, if I have pi halves and pi halves, 1 full cycle is going to be pi units. And if we look at our unit circle, 1 cycle is pi. Because look, when I go this way, look at, I have tangent values. But then when I hit here, I'm undefined. This right here is pi halves. So then if I go this way, once again, I have values, but here I don't. So tangent has a period of pi, not 2 pi, where sine goes 2 pi, cosine goes 2 pi. Tangent, it goes up pi halves, down pi halves. So it has a period of pi. So let's list some important facts here. Our domain. Now our domain here, every pi halves, you're going to have an asymptote. Every pi halves, we have an asymptote. So on this one, my domain is going to be x such that x cannot equal pi over 2 plus or minus, I'm going to put k pi. Now, the letter k is actually a scalar, meaning that can be plus 2 pi, plus 3 pi, plus 4 pi, because every pi units from pi halves is going to be an asymptote, or even if you minus it. Next, our range. If you notice, your range is going arrowhead to arrowhead. It is going to be negative infinity to positive infinity. Now, on tangent, we don't have any amplitudes because you don't even have a max and a min here. So my amplitude is going to be none. We have no maximum and no minimum. Because we are going to infinity and infinity. The period here is going to be pi units because I'm going to pi halves and then negative pi halves, and pi halves plus pi halves gives you pi. The frequency is a reciprocal of the period. So that's 1 over pi. Now, if you're ever asked, is this an even or odd function? Tangents are always odd. All tangents are odd functions. And what that means is if you plug in f of negative x, it's going to equal the negative of f of x. Let's go into some general rules before we start graphing some and start translating them. So in general, we are going to have the formula y equals a tangent of bx. Now it looks very similar to the function of sine and cosine. But here we have y equals a and then tangent of bx. This one's going to have a different period because sine and cosine had a period of 2 pi, tangent doesn't. So the a right here is still going to be the reflection over the x-axis. If a is less than 0, it is still going to be a vertical stretch and shrink. And when I say vertical stretch and shrink, remember right here how we went over 1, up 1? Let's say the a value was 2, you would go over 1, up 2, over 1, down 2. Okay, that's what I mean by the vertical stretch and shrink. A does not stand for amplitude. Here you have no amplitude. Now the B, which is between the trig and the argument, the variable, that's the B. It has to be in between. The B is going to be the period change. Now in sine and cosine, it was 2 pi divided by B. In this case, because the period is pi, it's going to be pi divided by B. And then the asymptotes is actually going to be x equals plus or minus pi divided by 2b. Because remember, the asymptotes here were at the pi halves. So that's why it's pi divided by 2b. Now, remember on the master one, on the parent one, this is one cycle right here. I went over pi halves, over this pi halves. You have 3 notches in the middle. You want to cross the x-axis in the middle and then go over 1, up 1, over 1, down 1. Okay, so those are 5 things that you want to remember, where the 2 asymptotes are and where the 3 points are in between. So right here, I am going to have the 2 right here in the front is going to be the reflection over the x-axis. If it's less than 0, which it's not negative, but it is going to be a stretch. So that's going to be a vertical stretch by 2. All right. Now, the B value here is a 1. You just don't see it. Okay. The B value is a 1. So when I'm doing my asymptotes, it's going to be x equals plus or minus pi over 2b. And in this case, the b is a 1. So it's plus or minus pi over 2 times 1, which is just plus or minus pi over 2. So I'm going to go to the right pi over 2, to the left pi over 2. Well, if I took pi over 2 and I divided by 2, that's actually pi over 4. So there are my asymptotes. Now, instead of going up to 1, I'm actually going to go down to 2 and up to 2 because my vertical stretch is 2. So now remember the 3 points in the middle, cross in the middle. And now when you go over 1, instead of going up 1, you're going to actually go up 2, down 2. And this is going to be 1 period right here. And if you want to calculate the period is just going to be pi divided by b. So the period here is going to be pi divided by b, and the b is going to be a 1. So the period is just pi. So let's see our domain. Our domain is going to be at every value except for all of the pi halves. So it's going to be x such that x cannot equal pi over 2 plus or minus k pi. The range, because I'm going arrowhead to arrowhead, it's going to be negative infinity to positive infinity. The period, we just calculated it, it's pi. And the frequency is the reciprocal. And then our asymptotes are going to be at all of the pi over 2s plus or minus k pi. Let's go ahead and let's change the period now. So right here, this is our b value. Our b value is 1/2. So that's going to be my b value. When I'm doing my period is equal to pi over b, which in this case is going to be pi over 1/2. So what happens is that 2 is going to flip up to the top. So the period is going to go 2 pi. The period is going to be 2 pi. And when I do my asymptotes, the equation is going to be plus or minus pi over 2b. So this is going to be a plus or minus pi over 2. The b is 1/2. Now the 2's are going to cancel, and I'm just going to be left with pi over 1, which is just going to be a pi. So I'm going to go pi to the right, negative pi to the left. Or take your period and divide it by 2. So half this way, half that way. And if I want to find the scale, I took pi and I divided by 2. So that's going to be positive pi halves. That's negative pi halves. So now here, I'm going to go ahead, because these are my asymptotes. I'm going to cross the x-axis in the middle. My amplitude, well, I don't want to say amplitude, sorry. The a value is 1. So I'm going to go over 1, up 1, over 1, down 1. Let's go ahead and graph another one. So on this one right here, the negative is going to reflect it across the x-axis. Now what that does, instead of going over 1, up 1, it's going to go over 1, down 1. So instead of going from negative to positive, it's going to go from positive to negative. That's what I mean by it reflects across the x-axis. So right here, it's going to reflect across the x-axis. And now my b value here is actually a 2 pi. So that's going to be kind of interesting because the b value is between the trig and the variable. So my period equation is going to be pi over b. Well, in this case, it's pi divided by 2 pi. So the pi's actually cancel each other out, and the period's going to be a half. Let's do the asymptote. The asymptotes is going to be x equals plus or minus pi over 2b. So plus or minus pi over 2. The b value is going to be a 2 pi, which in this case is going to be plus or minus. The pi's are going to cancel out, and I'm left with 2 times 2, which is a 4, and that's actually a denominator. So my asymptotes are going to be at positive 1/4 and negative 1/4. So it's going to be at positive 1/4 and negative 1/4. Those are my asymptotes. And then if I want to find the middle notch, if I take pi over 4 and I divide it by 2, that's actually 1/8. I'm still going to cross the x-axis in the middle. But in the past, because I'm going to reflect across the x-axis, it's actually going from up to down. So I'm going to go over 1, up 1 this way, over 1, down 1 this way. So the graph actually looks like this. And the period is a half, because a fourth this way and a fourth this way, and 1/4 plus 1/4 is 1/2. Last one. So this one has quite a bit of transformations. Let's start off at the very front. The negative. The negative is going to reflect it across the x-axis, reflect across x-axis. So keep in mind, it's going to look like this now. The 3 is going to be a vertical stretch by 3, a vertical stretch by 3. And now the b value here is a 1/4. So let's do our period first. Our period is given by the equation pi over b, which is going to be pi divided by pi over 4. If you want, go ahead and the 4 is going to actually flip to the top. Or I can write it like this. I'm going to write it as a fraction over a fraction. So then the outside, which is the 4 and the pi, those are the numerators. The inside, which is the 1 and the pi, are the denominators. So the pi's cancel it out, and you're left with the number 4. So think about it. If the period is 4, half of it's on the positive x value, half of it's on the negative x value. So I'm going to go 2 to the right and 2 to the left. Let's make sure. Asymptotes is given by x equals plus or minus pi over 2b. So we have a plus or minus pi over 2. The b value is pi over 4. Right here, the 2 and the 4, that actually reduces to a 1/2. So I'm left with pi over 2. That 2 is going to end up flipping to the top, and the pi's are going to cancel each other out. So if that happens, I'm left with plus or minus 2. So go 2 to the right, 2 to the left. Now, since I'm going to stretch by 3, I'm going to go up 3, 1, 2, 3, down 3, 1, 2, 3. And remember, it's going to go like this. So it's going to cross the x-axis in between. I'm going to go over 1, up 3 this way, over 1, down 3 this way. So you can tell it is stretching it out. Make sure you're not drawing it with straight lines, although it looks kind of straight. So this right here is going to be 1 period. Let's say I wanted to graph another period. I'm going to go 4 markings out because that's what the period, the period is, 4. So I'm going to go 4 more out. 1, 2, 3, 4. That's going to be another asymptote right here. It's going to still cross in the middle. It's going to go over 1, up 3, over 1, down 3. That's going to be another period. And if I'm looking at the scale, it goes 1, 2, this one has to be a 3, a 4, a 5, and a 6. And you can keep repeating yourself. And that concludes our notes.